all the additional information that's held in an engineer's head when he looks at stuff, contextual data, as well as physics. And some of that exists in documents, the fact that it's on this pipe and the flow goes in this direction. But then others of it is it's not documented anywhere. It's just because of the fact it's fluid, Bernoulli's equation applies, I guess. And so that makes me think again, the digital twin, another definition is, no, not a definition, a use of it. It's like a home for all this additional information. Or because the other thing that you described there is that you get a piece of data, but then it goes on a journey, and it picks up metadata as it goes. And this is actually a big difference between the spreadsheet way of doing it, because when it's in the spreadsheet, it's the bit of data. But when it's in a cloud-based digital twin environment, you see the data, but behind it's all this metadata saying what the system is it came from. Possibly the equipment related to it, that there's like a whole set of stuff hanging just out of view, but that you can access if you need to and that can give you traceability of stuff. We have a concept called status context in the barrier panel that allows us to take a piece of information and tag it with a context, like where it came from. But then when we calculate something from that it keeps its context, so it picks up all this baggage as it goes along. So when you get the result, you can always unpack it and see where it came from. I think that's a big difference from the old way of doing stuff, where you have an Excel tool that gives you your answer that you need to act on now, because you know all the rest, so it's fine. But if you wanted to hand that information to another system, you'd need to add all your knowledge with it so that someone could deal with it in an appropriate way, I guess.
Absolutely. And you started that piece with it's almost like a home for that data, and that's kind of how I see it as well. I think I've got way too many frames for way too many things, because I think it's valid for different conversations. But the layered approach, or the layered type of approach frame, is what I latch onto most. Is that it's having all that data housed, and again, depending on what your role is, that data is going to be completely different. It may be design documentation, right? It's all kinds of, it could be maintenance history. It could be maintenance, the forward plan for maintenance. It could be process data. And I think the digital twin is certainly where all that data is housed, but it's also those algorithms that do something with the data. It's the connection, whether it's a graph model or not, but it's the connection of all that data to make it relevant. And then that, that the other layers that go onto it is the ability to actually, what does that mean? It's almost like, it's almost like the twin is the answer giver, right? I just need to ask it the question. And if it can't answer a question that I've asked, then I need to code that up into the twin in one of those layers, right? And so it needs to have that capability, because the use case is going to be different for anybody, right? I mean, if you're a construction planner, your digital twin is a 3D representation of the facility, right? That's what I need as a construction planner to be able to plan that job. I'm going to need scaffold that's 30 feet up. I don't have access underneath, or I'm going to need rope access. And those are the types I'm going to have to do a lift, because there's a laydown area to go over to here. Mm-hmm. That would be their application of it, but the same process applies, right? There's as-built dimensional information of that facility. There is, and I would say that next step is, how do I get kind of a more accurate view of what's happening now than going back to as-built documents, right? And that's where, and we won't go this direction, but that's where you can get into robotics, right? It's as my means for continually updating my dimensional understanding of my facility, the condition of my facility, whether it be integrity and external integrity. But I mean, even if you take this into the economics space, right? I mean, I've when I was an executive assistant, all the financial memorandums would come through my desk first, and I would, the executive I supported said, I need your opinion on all these, right? Which was a great learning. And, I've seen dozens of them come across. When you back out and you see what it takes to create something like that, to do the economics and what's the NPV at this discount rate, and based on the variability of the reservoir and so on, there is a lot of work that goes into that. Right? And the reality is none of the fundamental data has changed. And so I can even conceptualize, this digital twin concept it's not just for a facility, here's the process, here is the workflow to build this, to create this, whether it be a financial memorandum or a production facility. And it's a means to be able to code up all those steps that happen in that process. So, and the output is even better, right? The output now becomes, not only is it quicker, but because it's quicker, I can make better decisions because I know that information is more real time, right? Instead of grabbing data, if it's a 3-month process to get a financial memorandum up to date, well, in 3 months, I probably drilled another prospect well. And I don't have those results inside this. And so now you're having a conversation on, should I invest further in this on bad data, or, which is more likely, you're having a conversation on this financial memorandum, which I've already read and I have my biases now. And then you're coming into the room saying, yes, but let me get you up to speed over the last 3 months. And so you're bringing new information into the room and potentially making decisions that are biased or aren't real time, right? With real-time data. So having a digital twin of these things allows you to basically get the broader context like that, if you set it up right.
But that's actually one of the most important things I think there is on the whole of digitalization, which is to get to a decision. And it's either the same decision you would have made before, but just quicker, or a better decision than you would have taken before. Because actually, if it doesn't lead to those things, it's just a fun project to work on, really.
No, it's really cool to have a simulator running against my system, right? But if I'm not getting value from it, then it is. It's just cool to look at.
It has to get you to do something. Yeah, that's exactly it. That's got to be the objective.
When you mentioned earlier, Murray, that look, the environment the upstream oil and gas business is in right now, it's how do I get my operating costs down? And, depending on who you talk to, it'll turn around and whatnot. But in the end, it is about getting your operating costs down, and your twin allows that as well, right? Is if I've got 100 engineers that are having to go in and look at data and respond when things are going wrong, the more I can codify that, the less people I need, because now they're working by exception, right? If I got in my twin, if I've got a transmitter, let's say I've got paired transmitters, 2 transmitters, one's a safety transmitter, the other's a control. I use it to control that system. I know just through simple logic that those 2 should be reading approximately the same thing because they're within inches apart. And if they're not reading the same thing, something's wrong. And based on if they're not reading the same thing, I can actually, if I were to trend them, I can determine which one's likely off, right? If one of them just tagged to the high, that's likely that failed, right? And if they just gradually trended off, I could use some physics based on that process to estimate which one's actually, drifting. And based on that, I can actually determine what type of action needs to happen, right? If it's completely tagged out at the top, it's likely we need to replace that transmitter. If it's drifting, it's likely we just need to recalibrate it. If it's drifted over and over the last several months, because I'm pulling my maintenance records, then it's likely I would just say, just replace the dang thing. the amount of time for examples like that engineers are putting into the system, if you will, you know, the example I just gave, I can give you the data. If I had a digital twin, I can determine when that's happening. I can do the querying to determine what the likely cause is and which transmitter it is. And I can pull maintenance data as well to determine what the action needs to be. And all I need to do is codify that up once and get 90+% of when I've got transmitters that are out of or either out of calibration or broken, right? And automatically get that into my maintenance system.
Yeah.
And again, using other information, I can actually put a priority on that. Does that need to be fixed today, in the next month, or get to it when you can, right? And I no longer need the hours that an engineer spent on that. And so you want to look at a way to get your operating costs down. It's your overhead.
Yeah.
It's that overhead cost. Unless someone's using a Ouija board or a crystal ball to actually make decisions, and if they are, I would probably focus there.
Sell shares immediately.
But if they're not using that, they're using fundamental rules and logic. Codify it.
That can be codified.
What the digital twin enables.